Check this out. We've got something really fun today. This is so amazing, man. Oh man, again?
Let's warm up. We want to match each of these absolute value equations to their graph. Now we see that two of them are quadratic absolute value and one of them is linear. So we can easily match this linear equation up with its graph here. The next one that might be easiest to match up is this one that was written in vertex form. It has a vertex of 3, -4. So when we look at this graph here, the vertex is definitely not at 3. Now if we looked at this one, yeah, the vertex could be at 3, -4, and looks like we took the absolute value and made it +4. So this one matches with this one. And then by elimination, this one matches with the first one, although we could easily factor this and find the x-intercepts from those factors to match that one up. 7.3 Solving absolute value equations. Remember that if we have the absolute value of x, if x is already positive or 0, the absolute value sign or function isn't doing anything, and so we can just drop it. And if whatever's inside the absolute value sign is negative, we can drop the absolute value sign, multiply it by negative, thus canceling out the negative coming from the whatever's inside the absolute value brackets, and then it becomes positive. So when we're solving these equations algebraically, we have two cases to worry about. We'll call the first one case 1. That's when the absolute value brackets weren't doing anything. They were useless, we're going to drop them. And that's when the stuff inside was positive or 0. Case 2, the expression inside the absolute value brackets was negative. First, let's try to solve these absolute value equations graphically. We can put the left side of the equation into y1, put the right side of the equation into y2, and then find the solution, and that will be where they intersect. So in this case, we've got x equals 4 and x equals 8. Now remember, we don't care about the y value here on the graph. We're just graphing it to help us solve it. There is no y value in this equation. Look at the next one. We've got two absolute value functions here, so this one would be very difficult to do algebraically, but no problem using our graphing calculator. So we find that the two intersections right there and right there are found at x equals -2 and x equals 3. Now I have seen students rearrange this equation and move it all onto one side, like this, and set the whole thing equal to 0. And then when you graph it, you will be finding the x-intercepts. Looks something like that, and the x-intercepts will be at -2 and +3. And this, of course, works. You've just added an algebraic step here, rearranging the equation, so there's potential to make a mistake. For example 2, we're going to solve these absolute value equations algebraically. We need two cases. Case 1 is where the stuff in the absolute value brackets is already positive or 0. And we need to know when that happens. When is x plus 5 greater than or equal to 0? So let's do some algebra. Subtract 5 on both sides, and we'll get that x is greater than or equal to -5. So we could say when x is greater than or equal to -5, then we are in case 1. And that is the absolute value brackets aren't doing anything. So we'll drop them. Drop absolute value and solve. So minus x on both sides, and probably add 1 on both sides. That gives us 6 equals 3x. Divide by 3 on both sides, and we get x equals 2. Now when I check x equals 2, it's definitely in this case because 2 is greater than or equal to negative 5. Now I need to do case 2. And that's the case where the stuff inside the absolute value bracket is negative. So case 2, drop absolute value and multiply by negative 1. Now it would be the opposite of whatever happened in case 1. So if this one was greater than or equal to negative 5, case 2 is when x is less than negative 5. And you don't need to redo the algebra. You can just take everything else for this case, unless it's outside the domain of the equation. But we won't have any questions like that. Now, we just drop the absolute value brackets like we did before, but we need to multiply by negative 1. And that's because x minus 5 was returning negative, and we need to multiply it by negative to cancel that out so that it's positive again. Now we just need to do the algebra for this. So we'll multiply in the negative sign here, and then add x on both sides, and add 1 on both sides. We get negative 4 equals 5x, and then divide by 5 on both sides, and we get x is equal to negative 4/5. And then we check our case. Now, our case 2 happens when x is less than negative 5, but this solution here we found isn't less than negative 5. So we're just going to cross it out and say extraneous, which is a solution we find algebraically that isn't actually a solution. Extraneous, therefore, no solution for case 2. So the only solution for this was x equals 2 from the first case. And we can check this graphically in our calculators. Give this one a try, pause the video and finish it. And when you're done, start this video again. We have two cases, case 1, and we need to find when that happens. So when is 4x minus 5 greater than or equal to 0? That will be our case 1, when we don't need the absolute value brackets because it's already greater than or equal to 0. So do some algebra, add 5 on both sides here. We get 4x is greater than or equal to 5, divide by 4, and we get x is greater than or equal to 5 over 4. So case 1 happens when x is greater than or equal to 5 over 4, or 1.25 if you prefer. Now let's actually solve it. Notice how there's two different things happening. I'm trying to figure out when case 1 is happening, and then I'm actually solving it. So drop the absolute value brackets because they weren't doing anything. Next, do some algebra and solve for x. And we get 4x equals negative 2, and divide by 4, we get x equals negative 1/2. But case 1 only happens when x is greater than 5 over 4. So this solution is no good. It's extraneous. Next, let's try case number 2. Case 2. Case 2 happens when x is just the opposite of this, when x is less than 5 over 4. When we drop the absolute value brackets this time, we're going to multiply it by negative. So just in case you don't understand why we're multiplying it by negative, x is less than 5/4, so 0. For instance, we put 0 in here, we get 4 times 0 is 0. Minus 5 gives us -5. Now the absolute value brackets would return us +5, but we've got -5 here. So by multiplying by negative, we're going to make that +5. Okay, we can't do algebra with the absolute value brackets in here. We don't have any way to move things in and out of those absolute value brackets. That's why we have to get rid of them. So now we've gotten rid of them. Now it's just regular algebra that we can all do. So -4x plus 5 plus 9 equals 2. This will give us, let's add 4x on this side. Add 4x on this side, -2 on this side, -2 on this side. And this will give us 12 equals 4x. Divide by 4 on both sides here. And we get x equals 3. Now again, we check with our condition. Case 2 is when x is less than 5/4. Well, 3 is not less than that. So this one's also extraneous. Therefore, there's no solution to this equation. Neither case worked. And if you checked graphically and graphed this into the first y1, this into the second y2, then you shouldn't find any intersections. Now we have a quadratic inside the absolute value here. So our case restriction is going to be a bit more complicated. So our case 1, when is x squared minus 3x greater than or equal to 0? Well, this is actually pretty easy to factor. So I'm going to factor out the x, and then I'm going to get x minus 3. And I'm going to do this graphically. So if I graph this, I have x-intercepts at 0 and 3. And I know this has a positive leading coefficient, so it opens up. Now, where is it positive? Where is this quadratic greater than or equal to 0? Well, that would be over here. So that would be when x is greater than or equal to 3. And over here. So when x is less than or equal to 0. So these are my two restrictions for case 1, where this quadratic is already positive. You can also figure out where it's positive using roots and test points. Okay, now let's actually solve this. So we've got x squared minus 3x equals 2. Case 1, I just dropped the absolute value. Bring the 2 onto this other side so it looks like a quadratic that we can deal with. I look at this, I don't think I can factor that, so I'll have to use the quadratic formula. X is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So clean this up a bit, and I get 3 plus or minus the square root of 9 plus 8 is 17, all over 2. Now, if I wanted my answers in exact values, this is as far as I could go because the square root of 17 is irrational. If I did want to round it, if my answers were rounded in this question, or it said to the nearest tenth or something, then we can get some decimal values from this. It's approximately equal to 3.56 and negative 0.56. I just need to check that with my restriction. So 3.56 is greater than or equal to 3, so that's good. So this one's a good solution. And this negative 0.56, that is good because it's less than or equal to 0, so it's over here on this side. So both of these are good solutions. Now let's do case 2, the case where that stuff inside was negative. Case 2. That would be whatever this one wasn't. So this would be 0 is less than x, and that's less than 3. So case 2 happens there. And now let's drop the absolute value sign like we did before, but multiply by negative. And then just do some algebra. This time I think I'll just take this negative and move it over here to this guy. So x squared minus 3x, and that will be a negative 2, and then I'm going to add it to both sides, so it'll be positive 2 here. Okay, now this one actually looks like I can factor it, so I'll do that to solve x minus 2, x minus 1. So that means that my two solutions are x equals 1 and 2. Now I just need to check with my restrictions. Looks like 1 and 2 are both in between 0 and 3, so they're both good solutions. So this question actually has 4 good solutions to it. Next example has a quadratic outside the absolute value and a linear inside. Case 1 is when x minus 5 is greater than or equal to 0. Do some algebra, x is greater than or equal to 5. So restriction on case 1. All right, now we actually go to solve it. So I've got x minus 5 here and x squared minus 8x plus 15. Okay, now for the restrictions, notice I'm only dealing with what's inside the absolute value brackets. Let's solve this. Let's move everything to the right side here. So we got 0 equals x squared minus x on both sides. So this is now minus 9x. And add 5 on both sides, so that's plus 20. Next, let's factor this to solve it. So we've got x minus 4 and x minus 5. That means that our two solutions are x equals 4 and 5. Now I'll look at my restrictions. X is greater than or equal to 5. So that means that this one does not work here. It's extraneous. Let's put an arrow to it just to be clear. It's the 4, not the 5. So that one's extraneous, but the 5 is good. Satisfies that restriction. Let's do case 2. So case 2 happens wherever this one doesn't. Restrictions on case 2, and that would be x is less than 5. We'll go through this whole solving again, except this time when we drop the absolute value brackets, we're going to multiply by negative 1. Okay, and then do some algebra. So we're going to move everything to this side, just like we did before. X squared, this is going to be negative x, so I'm going to add x here and here, so minus 7x. This one will be plus 5, so I'll have to minus 5 here, minus 5 here, so this will be plus 10 left. Then I will factor this to solve it, so x minus 5, x minus 2. That means that my two solutions here are x equals 2 and x equals 5. Now I look at my restrictions. X needs to be less than 5, and 5 isn't less than 5. This one's a bit tricky because 5 was a solution in the first case, but it's actually extraneous in this case because it doesn't meet our restrictions. So this one here is not restriction. This one here is extraneous, and the 2 is good. So just to be clear for this question, x is equal to 2 and 5 are final solutions. This is part of Relations and Functions 2, Graphing and Analyzing Absolute Value Functions. Hopefully you can solve absolute value equations graphically and algebraically. There's some questions, give them a try, see if you know what you're doing.